Hello Year 12s, welcome. In this video we're going to look at 8 standard graphs. So these are 8 shapes that you absolutely must know, and I'm hoping you remember some of them from last year, but we'll also encounter a couple of new things. So first, definitely need to do this. Need to label my axes. And you should all know what this shape is. Yep, and that turning point is at 0, 0. Alright, so we need to know the name of that graph. That is a parabola. You know this. And you need to know the equation, and I'm hoping you know that too. That's y equals x squared. Alright, next graph. You have to know this one as well. Label your axes. Instead of a turning point, this one's going to have a point of inflection just there. So remember what a point of inflection is. So it goes, the gradient's positive, 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 goes to 0. There's a stationary point there, point of inflection, then goes positive again. So let's have a look. That's 0, 0. And that is a cubic. And we know the equation for that is y equals x cubed. Alright, let's just make sure that we've got the name of that point there. So that point there is a point of inflection. Different to a turning point. Alright, next. So we're going to introduce a new number that you won't be familiar with for this graph. So this number, it's kind of like pi, like its digits go on forever. And we'll learn about it a bit more later. But this number is called e. And e is roughly equal to, we're going to do a few decimal places of e. It's 2.7182818, so on. It goes on forever like pi. This number is very special. We'll get into why it's special later. But there's a graph we need to know, and that graph is y equals e, which is this special number, to the power of x. Alright, so this is what this graph looks like. There's an asymptote here along the x-axis where y equals 0. And it starts from this asymptote. And whoops, drawn that poorly. Starts from this asymptote and it goes up and up and up and then it just shoots up like that. That point there is 0, 1. Because remember, anything to the power of 0 is 1. And let's make sure we put in our asymptote. So I should be doing this with a ruler. Put in our asymptote. We'll always make it very clear when we put in our asymptote. Even if it's over an axis, we still put it in. And that asymptote is y equals 0. So there's a sort of new one with the new number e, and we'll learn about that more. If we reflect this graph in the line y equals x, we get another graph. And this graph is going to be a special type of log graph. Its equation is y equals log base e of x. Or you might see it written as y equals, and more commonly written like this, it's the letter L and then n and then x. So this e here, it might be called the natural number. It's sometimes incorrectly called Euler's number, but that's okay. It's the natural number. This here, this ln, is a shorthand for log base e. So you can read this as the logarithm with the natural number, or we just say the natural log of e. Sorry, the natural log of x. We'd call this the natural log of x, just like this. This is the natural log of x. And this graph, well, this graph has an asymptote, so it's a reflection in y equals x. So it's got an asymptote going down here instead. And that asymptote is called x equals 0. And it looks something like this. And that's going to be 1, 0. Notice, and you don't have to write this in, but notice how if I draw in the line y equals x, that's the line y equals x there, you can see how the natural log of x is the inverse function. So that's the inverse function there. It's flipped in the line y equals x. So if you remember your inverse functions, that should make sense. So there's 4 of your graphs. In the next video, we're going to go through another 4 graphs, which we should already be familiar with. Okay.